All right, so today in class we are talking about how there isn't just a first ionization energy, but you could have a second and a third and a fourth, a fifth and a sixth. The general trend that you guys want to recognize is that every electron that you pull out after your first, the numbers are always going to get bigger for your subsequent second, third, fourth, fifth, sixth ionization energies. And remember the definition of what ionization energy is. It's just the energy required to remove an electron from an atom. Okay, so I wanted you guys to take a look at this little trend pattern that we see here. You could see that for the first ionization energy for this element, or whatever it is, we're going to come to figure that out soon. But the energy needed is 1,086 kilojoules. This one requires 2,500 kilojoules, 4,600, 6,200, and then all of a sudden between the fourth and the fifth, you guys should notice that there's a really huge spike in the ionization energy here from 6,222 going on to the fifth ionization energy. It gets to 37,829. So there is a very obvious spike right here when you're trying to remove that fifth ionization energy. And then for your sixth ionization energy, we get to 47,000. So one thing you could kind of deduce from all these numbers here is that as you pull off the first and then the second and then the third and then the fourth electron, when you try to pull off the fifth, all of a sudden we need a huge amount of energy relative to all these other numbers that you guys saw here. So this pretty much tells us very clearly that there are 4 valence electrons inside this atom. Because again, you took off the first one, the second one, the third one, the fourth one, and then once your valence electrons are done, for this fifth electron that you're trying to pull out here, we're trying to pull off an electron from a full p6 orbital, which, you know, is not going to want to happen because this is stable, right? So it takes so much energy to pull it off. And you could take this a little bit further, which is what I was telling you guys in class today. If I told you that we're looking at, let's say, the third period on the periodic table, and period, you guys want to remember, is just the row of the periodic table. And if we're checking out the third period, let me just show you on the periodic table where period 1, period 2, period 3, I'm trying to find an element here that has 4 valence electrons. So it would be sodium, magnesium, aluminum, and then silicon right here is our culprit with 4 valence electrons. So I could say pretty confidently that if I know what period all these numbers really pertain to, I could easily identify what the element is going to be. Okay. If I change this a little bit and just kept the numbers all the same, but I said I'm looking for an element that is on the fourth period with 4 valence electrons. You guys look here, this is period 4 right here. So 1 valence electron, 2 valence electrons, we skip over the d elements. And then 3 valence electrons, 4 valence electrons. So germanium right here is going to become our element that we have this lovely little trend for ionization energy. And that's it.